I wanted to play a little bit too. So 1207410911101 and JFKFBIUPSNIRSNASA. It's all about encoding, how you're going to work with the information and modify it to fit into the entire system of memory. So Mr. Woodard talked about encoding, and he talked about different background terms regarding encoding. We're going to give you tips and tricks as we go along here. I want to give you some more background information as far as the other couple of parts of memory, and that is, first of all, storage. So you encode it so that you can store it and keep it in the brain so that in the end you'll be able to retrieve it. It might be next week, it might be next month, it might be 5 years from now, but you've got to keep, excuse me, that the memory system is made so that if you've encoded it properly, then it will store for a longer period of time. So one of the cool things about memory is the fact in our brains in general, and this is a term that comes up constantly in the text, is the idea of parallel processing, that our brains are working with a lot of information at one given time, even if we aren't consciously thinking about the information. So right now I'm looking at a computer screen, but my brain is taking in the picture that's over here. There's a lamp over here, there's a calendar over here, there's a cup of coffee right here, there's a screen right here, there's window blinds, there's lighting that's coming in, there's lighting behind me, there's all this stuff going on, and that's all just visual. That's not just to mention all the auditory stuff, a heater that's coming on or a fan that's going, whatever it might be. The brain is taking that in at the same time. So that's the parallel processing. Whether we are thinking about it consciously or subconsciously, the brain is taking in the information and dealing with the contextualization of that moment on various levels. So with all of that information coming in, how exactly do we form memories? Well, one of the big things, I'll move my screen up here. One of the big things in this particular slide, one of the big phrases to keep in mind is that the memory stages are encoding and storing memories in their different ways, but they work together. They're all working together in order to form memories or throw information out. They're saying it's not important, we're going to toss this out, we're not going to remember this. So when we need to remember certain pieces of information, we have to make sure that our brain is working and that memory system is working to keep that information stored, encoded properly, stored so that we can more easily retrieve it later on. All right. So the three main stages of memory. Okay. First of all is sensory memory, then working memory. We also call that short-term memory, and then long-term memory. So, sorry, my cursor here. There we go. Sensory memory is going to preserve brief sensory impressions of stimuli, just real quick. So, on the next slide, I'm going to just flash a series of letters for 1 second. I know that this is on a video and it's a smaller screen. You'll get the point here. So I'm going to hit my next slide and you try to remember as many letters as possible. It's literally going to be about 1 second long. Okay, here we go. Okay. Try to remember how many letters or which letters that you saw. And there's the correct answer again. And the point of this particular exercise is the fact that sensory memory is about 12 items. You can keep about 12 items, and there is only 9 items in your sensory memory. The problem is it only lasts for a few seconds. So I kind of dragged out the next screen after you saw it. I dragged it out a few extra seconds. So you probably didn't remember all 9 of the letters because the sensory memory is very, very fleeting. Okay, it's the reason that we often hear something even after we say what. You'll be in a conversation and somebody will say something, you go, what? And then as they start to say it back, you're like, oh, I know what you said. We hear things, but our brain has to process what we heard. And so that sensory memory is kind of pulling back what they had just heard. And our inclination is if we don't register it right away, we just say what real quickly. While our sensory memory is saying, wait a minute, oh, here's what was said. Okay, we've all had that experience. there's a separate sensory register for each sense. So Mr. Woodard had mentioned iconic memory, or this visual memory. That lasts almost instantaneously. It's less than a second. So that's what you did with the letters on the screen a couple of slides back. Echoic memory is auditory memory. That lasts a little bit longer. That's why if we say what too quickly, the sensory memory, the echoic memory, is actually has the information stored. It remembers what it heard. It just takes a little bit longer to process, but at least it's in there for a few seconds more. And that's why you can figure out what was said even after you said what. Okay. The next stage of memory is working memory. This is where and this is a crucial stage of memory, because Mr. Woodard kept talking about you have to work with information in order to properly store it. And the working memory is where that work takes place. So working memory is going to preserve recently perceived events or experiences for less than a minute. So you've got a little bit more time, obviously, than the sensory memory. And the famous number to remember with working memory is 7 plus or minus 2 items. And the easy example is phone numbers. Phone numbers are 7 digits long because years ago when they were developing phone numbers, they knew that memory works with 7 digits. So that's why we have 7-digit phone numbers. It's interesting you add an area code in there, but what do we always do with an area code? We put it in parentheses. We separate it from the rest of the 7 digits. Okay, and we'll talk more about what's called chunking later on. Mr. Woodard will probably pick that up in the next video. Okay, so working memory or short-term memory, and we like to abbreviate STM. Remember, 7 plus or 2 plus or minus 2 items. That's the magic number with working memory. Okay. Working memory consists of several different parts of the brain and pieces of the brain that are working together. So it kind of funny terms, interesting terms, but a central executive which directs attention to the material retrieved from long-term memory or input coming in from sensory memory. This is what I meant when I said that working memory is where that work takes place. Working memory in that central executive, that part of our brain that's going to say, all right, here's what I've got from long-term memory. I'm going to bring that up. I'm going to retrieve it. I've got this new stuff coming in from sensory memory. I'm going to work to latch that sensory memory onto the long-term memory. Okay, I'm going to work with something in long-term memory, something I know pretty well. I'm going to attach this new information to it so that it will stay in long-term memory for a longer period of time. It also there's a part of the brain that is called the phonological loop. So this is the part that's going to temporarily store sounds, and then the sketch pad, which is going to store visual images. Okay, so there's different parts of the brain that are going to pick up and try to store the senses that are coming in at any given time. And remember, the brain is doing this at parallel times. It's hearing, it's seeing, it's starting to record, it's starting to encode, it's starting to store, and it's retrieving at the same time in order to get the new information to latch onto old information. So that's that parallel processing that's always happening. Okay. All right, I'm going to stop there because I've talked about 8.5 minutes, and Mr. Woodard will take over.